Okay, class, let's talk about the gallbladder. Let's go step by step with this document. Chyme enters the duodenum, causes release of CCK, which we talked about in secretin, from the duodenal cells, enteroendocrine cells. Okay. CCK, red dots, and secretin enter the bloodstream because they are hormones. They are hormones. Okay. CCK induces secretion of enzyme-rich pancreatic juice. Okay. Secretin does the electrolytes and the bicarb. Secretin, electrolytes, and bicarb. CCK does the enzyme juice from the pancreas. But CCK also, remember, stimulated the gallbladder. So CCK is doing pancreas enzymes and gallbladder contraction. Bile salts, to a less extent secretin, transported via bloodstream, stimulate liver to produce bile more rapidly. Okay. The bile salts came from where? The gallbladder, sending it in. CCK via bloodstream causes gallbladder to contract and hepatopancreatic duct to release. And then during cephalic and gastric vasal nerve stimulation called weak contractions of gallbladder. Okay, so the gallbladder is contracted because of what? CCK and a little bit of acetylcholine, but not much. That's where the cephalic phase. So we go back. What does secretin do? Secretin causes bicarb to come. Okay. Enters the CCK induces secretion of enzyme-rich. Secretin causes secretion of bicarb. Okay. CCK does what? Increases the output, okay, of digestive juices, secretive that contract the gallbladder but found throughout. Intestinal feedback. So read through this so you can see as a summary. CCK contracts the gallbladder and causes the pancreas to secrete enzymes, digestive enzymes. And secretin does the bicarb and electrolytes from the pancreas. Secretin does the bicarb. All right, let's go further here. So digestion in the small intestines. So now we're in the small intestines. Chyme from the stomach contains partially digested carbohydrates and proteins. That's coming from the stomach. Undigested fats. Okay, partially digested carbohydrates and proteins. Let's think about this. Carbohydrates because of salivary amylase. Proteins because of the stomach doing pepsin. Undigested fats because all you had was a little bit of salivary lipase and that was it. It didn't do much. Gastric lipase, remember, is minimal. Very minimal. Particularly in the adult. So fats have not had much done to them. Okay, let's go further. Requirements for digestion and absorption. The intestine must get slow delivery of hypertonic acidic chyme. Remember, tonicity has to do with number of solutes. And coming into that tiny small intestine is a lot of solutes, hypertonic, and acidity from the stomach. Remember how we talked about 3 cc's shot out. Of 30, some goes back. 3 waves per minute on the stomach. Okay? So about 9 cc's, let's say, per minute. If the hypertonic chyme was delivered to the small intestine too quickly, it would pull too much water from the bloodstream. Now this here, that condition can sometimes be called the dumping syndrome. Complex physiologic response to rapid emptying of hypertonic contents into the duodenum and jejunum. Dumping syndrome occurs as a result of subtotal or total gastrectomy and associated, but it can happen also if you had a floppy pyloric sphincter. So there are other reasons. It doesn't always have to be gastrectomy, for losing weight and so forth like that. But that's the dumper. You cannot put it in because it'll pull too much water in and cause distension and all kind of bloating, flatulence, pain, diarrhea, all this. Additionally, chyme is quite acidic. So remember that chyme is acidic in the ulcer formation. Remember I mentioned the most common ulcers are really duodenal ulcers. Okay, let's go further. The small intestine only provides brush border enzymes. Okay, only provides brush border enzymes. That's that brush border. Okay, let's see what this is. Okay, only provides brush border enzymes. Most chemicals in the small intestine come from the pancreas and the liver. Liver for bile, pancreas for the enzymes we talked about. The liver, bile enzymes, bicarb, and so forth. We've talked about that. Intestinal motility mixes chyme with pancreatic juice, results in segmentation waves. Now, the small intestine has two kind of waves. Let's just hit this. It has peristaltic waves, but that's after you've done absorption. We're going to talk about it in a minute. But when the food goes in, that chyme goes in, you want to segment it and ripple it. So you want to break it into smaller pieces to give increased surface area and kind of bounce it up and down a little bit to mix good with the what? With the digestive enzyme. So segmentation waves occur when the chyme enters the small intestine. Peristalsis is after you've done all the work. So that's the secondary type of thing. Intestinal motility mixes chyme with pancreatic as a result of segmentation waves. The smaller mainly uses segmentation waves. Peristaltic waves begin after the materials have been absorbed. That's to push it along. This is to mix it, and that's to push it along. Okay. Segmentation waves make the intestinal chyme appear as if they are being massaged. The chyme is moved back, forward in the lumen a few centimeters at a time. Initiated by intrinsic pacemaker cells located in the circular muscles. But unlike stomach pacemaker cells, which have only one rhythm, the pacemakers in the duodenum, which is the first part, are about 12 to 14. See, that's where remember, that's where the digestive enzymes are coming in through that hepatopancreatic duct. And they just keep going a little bit down to the ileum. But the ileum, you should have done all your mixing primarily in the duodenum and the jejunum. Remember, the jejunum is the second part of the small intestine. Mixes and moves contents slowly and steadily towards the ileocecal valve. The ileocecal valve, just to show you, is the valve where the small intestine enters the large. We ain't got to the large. So there's the cecum, and that's the ileum. So it's trying to move stuff along slowly towards the end of the small intestine. Another way is to say it to the end of the small intestine, giving plenty time to complete digestion. The intensity of waves is altered by long and short reflexes. The segmentation waves in the late intestine wane in the late intestine because you do most in the duodenum. Once the segmentations wane, then the peristaltic waves begin, because the peristaltic waves are to move it down to go into the large intestine. But you don't want to do that until you've adequately mixed and absorbed. Let's go further. Motility, peristalsis. Here's peristalsis, initiated by something called motility. Now, motility stimulates gastric and intestinal motility, released by the duodenum and jejunum, released and is stimulated by nerves, fat, and acid. So that motility initiates the peristaltic waves. They're almost ready to go. As motility blood levels rise, peristaltic waves initiate in the proximal duodenum every hour and a half to 2 hours and sweep along the intestines, dying out 2 feet from where it started. And what happens is this migrating motility complex, so they move 2 feet, then die out. Then another set starts there. So they move 2 feet, then they die out. Then another set picks up from there. Then another set picks up from there. So those pacemakers in there, the migrating motility complex keeps propelling this down. A complete trip from the duodenum, first part to takes about 2 hours. Okay? The process repeats itself. The meal remnants, bacteria are sloughed off. See, a good thing about propelling down is this. This is a housekeeping function critical to prevent overgrowth of bacteria that migrate from the large intestine. See, in the large intestine, you have a normal flora. We've mentioned that a little bit already. As food enters the stomach with the next meal, peristalsis replaced by segmentation. Okay. Once you eat another meal, see, at that point, you need to start back on segmentation to mix again and stop the peristalsis, so you don't move it through too quick. Motility of the local enteric neurons coordinate intestinal motility. It depends on which neurons are activated or inhibited. Cholinergic neurons, acetylcholine, may activate them because, see, remember, rest and recluse, parasympathetic, causes contraction of muscles and so forth. Okay. Most of the time, the ileocecal sphincter, let's go to that. Most of the time, this is closed, so you don't get into the large intestine. 2 mechanisms open it. The stomach initiates a gastroileal reflex. See, once stuff gets in the stomach, it knows it's going to have to eventually clear from the small intestine. So if you already had stuff in the small intestine, you have to clear it out to go into the large so the stomach can empty. So the stomach can't empty if you still have too much in the small intestine. So the stomach initiates a that means stomach, ileal to the ileum reflex that enhances force of segmentation in the ileum to kind of get things moving, to clean this ileum out. Well, first of all, to get the last part of absorption, and then to clean it out. Gastrin increases motility also. The gastrin, remember, there are 2 gastrins. One was produced in the stomach and the other in the small intestine, and they also try to open that valve so you can clear out into the large intestine. Okay. So now we're to what? The large intestines. Okay, so new video.